let us continue to route flood hydrograph. In flood hydrograph, we'll discuss about routing flood hydrograph. Route the following flood hydrograph through the reservoir by using Goodrich method. For reservoir routing, there are 3 methods. The first one is modified pulse method, and the second one is Goodrich method, and also the third one is the fourth order or Range-Gutta methods. Now, among those methods, these examples can be computed by using this Goodrich method. There is a given data, elevation, storage, and outflow data. In the first column, there is in this column it is elevation data, and the second column it is what? The storage data in mega meter cubed, and it is in meter cube per second is storage data. This data is already recorded in the past, and also the second table, and this table too is the flood hydrograph data, or the inflow data that join to the reservoir. So this data is inflow data when at the initial condition. That means when t is equal to 0, the reservoir elevation is 100.6 meter. Those are the two tables, and this initial condition are the given. Then we come to the solution. Now, step 1, choose time interval. Hence, t is equal to 6 hours, and it is equal to 6 times 3600. It is equal to 0.0216 megasecond. And step 2, prepare Q versus elevation, and 2s over change T plus Q versus elevation curve or table. So by using this developed curve and tables, we can estimate the discharge and elevation of reservoir. Elevation of reservoir. So when you come to this table, then the first one is row 1, it is elevation already given, and the second one is what? The outflow, it is already given, and the third row is storage in megameter cube, it is also given. And 2s over change in T plus Q1, it is computed by using what? 3.35. For example, at elevation 100, the 2s over change in T plus Q1 can be calculated by using this formula. 2 times 3.35 over 0. Change it is equal to 0.0216, then plus 0 at the elevation, this elevation, or at 100 elevation of the reservoir, the discharge is what? 0. So this indicates that 100 elevation, it is the crust level of the spillway. When you come to this is 3.35, it is the useful life of reservoir. It is useful Then the remaining is s over 2s over change T plus Q1 can be computed like this. And after preparing this table, we can express this data in terms of in graphical form. So this graph is said to be, this graph is elevation versus 2s over change in T plus Q curve, and this graph is said to be what? The outflow hydrograph, that is the elevation versus outflow. Outflow hydrograph. After preparing this curve or a table, just we can route. Step 4, route the flood hydrograph when t is equal to 0 as the elevation of 100.6 meter. As this elevation Q is equal to 13 meter cube per second, the values are obtained by interpolation, and also I1 plus I2 plus 2S1 over change plus Q1 is equal to QS2 change T plus O2 Then this is Goodrich method. Yeah, it is Goodrich method. So by using this Goodrich method, we can estimate the or we can estimate the downstream hydrograph, or we can route the plate hydrograph in order to get the downstream hydrograph. So this Q is equal to 13 meter cube per second gets from this graph or the above table by using interpolation. Just after computing this value, then we can determine Ts over change it plus Q from not form. Yeah, it is not form, it is from. Yeah, from a noun value of Q is equal to 13 meter cube per second and the elevation of 100.6. Then by interpolation from the above curve or from the above table, then by interpolation Ts over T Q1 is equal to 300 minus 333. Sorry, wait a few minutes. Okay, then this value Ts after computing Ts over T plus Q1, then we can determine Ts over T minus Q is equal to Ts over T plus Q1 minus 2Q. It is equal to this 33 minus 2 times 13 is equal to 307 meter cube per second. For the first time interval, that means 0 and 6 hour, I1 is equal to, or the inflow is equal to 10 and I2 is equal to 30, sorry, and Q is equal to not Q. Yeah, it is not Q, sorry. It is not Q. It is a mistake. S to S, sorry, over T, okay, plus Q1. It is not Q. Yeah, it is typing error. So S to S over T plus Q1 is equal to what? How much? It is 347 meter cube per second. It is what? The value that used to determine the elevation for the Q2 and elevation 2 for routing. Yeah, that means this elevation can be used to the discharge at 6 hour and the discharge at what? At the elevation at the 6 hour. So by using this, we can determine the elevation is outflow at 2s over change T plus Q1 is equal to 347 meter cube per second. By using interpolation from the above graph, then the elevation is equal to it is 101.01. Yeah, it is 1.04 meter. Yeah, 0.04 meter. Then and the discharge is equal to how much? 27.6. This point. Yeah, 0.6. These values can be computed by using interpolation. Yeah, the interpolation. These values can be in this, when you come to this table, 106 meter. It is laid between 101 and 101.5, and also the discharge laid between 26 and 46 metrics per second. So by interpolating between these two values, we can estimate the discharge, that is 27, yeah, 27.6. Yes, this is a computation table. Yeah, this at is equal to 0, 100 meter and also 30 meter. The summation is 40 and also it is S over T minus Q. It is already compute from this value. Yeah, do you remember? From this value, yeah, subtract minus 2 times what? 2 times 130. We can get what? 207 meter cube per second. After calculating this value by sum up the two values 40 and 307 give us what? This value for the next time steps. And by using the above curve and tables, we can estimate the elevation of this value. And also these values can be estimated. Then by using this value and elevation versus discharge curve, we can estimate this value by interpolation. Yeah, it's calculated by interpolation. So for the next time interval, that means between 6 hours and 12 hours, the sum of the initial inflow and the second inflow 30 plus 85 115, then 291.8. by sum up, this can be calculated from what? By using this discharge, yeah, this discharge and this value. By subtracting 2 times this amount of discharges from this value, then we can get what? This amount of value to 291.8 meters. So by sum up, 115 plus 291.8 is equal to this value. So by using, we can get this and this value. So these processes can be should be proceed until the entire of the inflow hydrograph. So the last one is this. Yeah, the last one is this. Among these, the peak discharge. Yeah, this is a peak discharge. It is peak discharge. Peak discharge. Yeah, from the inflow, the peak discharge is what? This is. Yeah, this is a peak discharge for inflow. This is a peak discharge for outflow. So from this we can calculate the attenuation. Yeah, from this we can calculate the attenuation. Attenuation means it is the distraction or the reduction of the peak inflow discharge when you pass through the flood waves among the reservoir, through the reservoir. When you join to the reservoir, there is the reduction of the peak discharge. So that is attenuation. So the amount of attenuation is equal to 140 minus 123.8. I think it's equal to 10 point something. Yeah, 10 point something. I think can calculate it. And this is the step 1. When you come to the next example, it is channel routing. Sorry. Okay, route the following flood hydrograph through a reservoir reaches for which k is equal to 12 hours, sorry, and x is equal to 0.2. At the start of the inflow flood, the outflow discharge is 10 meter cube per second. Then there is inflow data. So this is channel routing. So channel routing can be estimated by using Muskegum method. So the solution for this method, first choose time interval t that should be satisfy the condition to kx less than t less than k, since k is equal to 12 hours and 2kx is equal to 2 times 12 times 0.2 is equal to 4.8 hours. So we can take 6 hours. It is laid between 4.8 and 12 hours. After determining this, after choosing a time interval, then determine the coefficient of C1, C2, and C3. C1 is equal to Tkx plus T over 2k minus 2kx plus T is equal to 0.429. Yeah, it is how much? It is 0.429. Then the second one is x2, it is negative kx plus T over 2k minus 2kx plus T. It is equal to this value. This value is very simple, yeah. Then C3 is equal to k minus 2kx minus T over 2k minus 2kx plus T. T is equal to what? This value, 0.523. So, after computing the three constants of a channel routing or Muskegum method, then you should be check the summation of these constants. Those constants should be 1. Then check C1 C2 plus C3 is equal to 1. Then it is okay. Yeah, it is satisfied the condition. If the summation of these values divided from or greater than 1, you should be reduce the largest value by subtracting the summation of the two smallest value from what? The largest value. Then determine the discharge at each time interval or at each time incremental by using this equation. This is Muskegum equation. Masking equation. So by using this, we can estimate this table. This is C1, it is already how much? 0.429, and it is also 0.048, and it is also 0.523. So by using this value, we can estimate this. At t is equal to 0, the initial and the outflow is constant, 10 meters per second, and also it is 10 meters per second. So C1 times 10 it is equal to this, and this is already sum up. Yeah, it is nothing. That means this value is equal to 0.429 times 10 plus 0.048 times 20 plus 0.523 times what? Q1. It is 10.48. It is discharge. Yeah, it is discharge. And when you come to 6 time interval 6 and when you come to this, the next time interval 20 and 50, then the first I1 is equal to 20 over 50, then 8.58. There is the sum up. By sum upping this value, you can get this value. That means 20 times what? This value, and 50 times what? This value. So okay, then we can sum up this three value, so we can get 16.46. Okay. It is very simple. So from this, there is a peak discharge is equal to 49.16. Is a peak discharge to peak. peak. Yeah, it is peak time. Then just move to next exam. It is assignment 1. So this is assignment. Yeah, this is assignment for our viewer. Yeah, our viewer. So you can submit by this email. @gmail. Okay, yeah, it is enough. @gmail.com. ይበልጣል ዘውዱ 21@gmail.com. Yeah, by you can send it after computing your value in this email. Now, a detention reservoir was found to have a linear storage, that is relationship. Then shows that the storage routing equation of an inflow hydrograph through the reservoir Q is equal to C1 average I1 ቢሮ ነኝ ና ተሎና ቢሮ ነኝ ቢሮ ውስጥ ነኝ ተሎና ስራ ይዤ ነው። Then C2 Q2 where C1 and C2 are constants and I average is equal to I1 plus 2. We can 2 over 2. Then determine the value of C1 and C2 in terms of K and routing time interval change in T. Then goes to a solution. Since S is equal to Qx and I1 plus I2 over 2 is equal to I average, it is already given. Then S2 minus S1 is equal to Q2 minus Q1 X1. That means this is what? This is the reservoir routing and reservoir routing. So this reservoir routing change in S is equal to Q2 minus Q1. Then it is change in S is equal to what? K2 minus Q2 minus Q1. It is equal to what? This is a continuity equation, or it is water balance equation when you consider the when you consider its catchment area. It is when the change in S, it is equal to inflow minus what? Inflow minus Q. Yeah, that means the inflow minus the outflow is equal to the storage rate of storage. It is equal to change of storage. Yeah, this is that formula. Then S2 minus S1 is equal to Q2 minus Q1 is equal to I1 change in T minus Q1 plus Q2 over 2 change in T. It is average. I bar means it is average. That means this is, yeah, this is, and Q, it is Q average. Yeah, it is Q I average. So it is the inflow average, it is the outflow average from the river reach. Then by rearranging or by collecting the terms, the common terms, so Q2 plus Q2 over Q2 change in T over 2 is equal to I change in T minus Q change in T over 2 plus Q1. Then Q2 into K plus change in T over 2 is equal to this value. Q2 is equal to what? Q2 is equal to change in T over K plus change in T over 2 I bar plus this value and this. So this means this is Q2 is equal to change in t over 2k plus change in t times I bar plus 2k minus change in t minus change in t over what? 2k plus change in t then q2 is equal to c1 i1 bar plus q2 q1 then c1 is equal to this value and this value. So by using this Zabbab relationship you can determine the equation b c1 is equal to 2 times 2 over 2 times 4 plus 2 is equal to 0.4 and when you come to c2 0.6. so check the two constants is equal to summation of the constant is equal to 1, then 0.4 plus 0.6 is equal to 1, then it is satisfied. When you come to the last one, then q2 is equal to 0.4 I bar plus 0.6 q1 and go to a solution. Then I1 is equal to 0, I bar is equal to the summation of two consecutive inflows, amounts of inflows over 2. Then 0.4 I bar plus 0.4 q1 is equal to this value. It is similar to the examples 3. Then we can compute like that. Then 10 times 0.4 it is 4 plus 0 times 0.6 is 0, then sum up this give us 4. And also when you come to the next time interval, that means 2 and 4, I1 it is 20 and I2 is equal to 60, then sum up and calculate the average one, it is 40, then multiply by 0.4 you can get what? 16. And also 0.6 times q it is 40, not is 4, then 2.4. so sum up these two value 16 plus 2.4, then we can get 18.4. so the remaining can be calculated by using this manner. Then among this discharge the largest values it is 0.9 said to be peak discharge. This discharge can be used to design it may be spillway or it may be culvert or any hydraulic structures. So this is flood routing. This is the blue one, it is inflow hydrograph, and this is the outflow hydrograph. So the difference between the two peaks among this it is attenuation. Yeah, it is said to be attenuation. And the difference between the time peak of the inflow and the time peak of the outflow hydrograph, it is said to be translation. Sorry, wait 5 minutes only and I will back. Okay. Example 5. It is chapter 3, flood frequency computation for river at the dam site by using gambles yield the following results. Return period is equal to 50. The picture charge become 40,809 meter cube per second, and return period is equal to 146,300. Estimate the flood magnitude in this river with a return period of 500. This is it is very simple. Yeah, it is very simple. Then first determine what is the general frequency analysis equation should be identified. This is the general frequency equation. It is equal to x. It is equal to x bar plus kt, that means frequency factor at a given return period, over standard deviation. Yeah, standard plus times standard deviation, sorry. Yeah, x it means it is flood magnitude, that is root 2, it may be for a design period, and x bar means it is a mean of a data series or the average of a data series. Then delta n minus 1 is the delta minus is standard deviation. So among this the above table, by using this table we can develop two equations. X at 100 is equal to what? X bar plus k at return period of 100 times standard deviation of a data. And also the next equation, it is like size, it is equation 1, and assume it is signed as equation 2. Then by using simultaneous equation, by using a simultaneous equation, this and this equation 2 and equation 3, then we can rearrange like this. K 100 minus K 50 over delta n minus 1 is equal to x 100 minus x 50 is equal to 46,300 minus 40,809 is equal to 5,491. So from this is the difference. That means q at 100 return period minus q at 50 times delta or standard deviation, it is equal to what? 5,491. So but kt is equal to yt minus yn over sn. Yt can be, these values can be calculated by using what? This can be calculated by using a return period. Yeah, yt it is vary with a return period. When return periods are changed, it is also changed. Yeah, but sn and yn it is constant. It is only depends on the number of data or data series. So y at return period of 100 minus y 50 is equal to delta n over sn. By substituting this equation, on this equation, then we can get another equation, this equation. So yt can be estimated by using this formula. Yt is equal to yt is equal to minus ln times double ln this bracket t over t minus 1. This what? This is the equation for estimation that is used to estimate return period yt at different return periods. ይሄኛው የሚያገለግለው ምንድነው? ytን ለምሳሌ ከዚህ በላን ዳብል ላን ካደረግን በኋላ እቺ ቲ ናት፣ እቺ ቲ ማይነስ ነው ዋናት ዜን እቺ ማለት ቲ ናት ማለት ነው ሪተርን ፔሪድ አት ጊቨን ሪተርን ፔሪድ ናት። እቺ ደግሞ አንድ መቀነስ ናት ማለት ነው። ስለዚህ ሪተርን ፔሪድ yt at 100 ሪተርን ፔሪድ ላይ ይሄ ይመጣል፣ 50 ላይ ደግሞ ይሄ ይመጣልናል ማለት ነው። ዜን by substituting this value on this equation, by substitute those value, 6.4616 and 3.19 on this equation, you can get this equation. Delta n minus standard deviation over STN is equal to 7,864. Then for return period 500 yt or yt at 500 year is equal to calculate by using it is value and y minus y100 can use this formula. This formula, the formula is this formula. It is standard. It is standard. So y50 minus this value delta minus 1 is equal to what? x50 minus x of 100. That means xt at return period of 500 and x is equal to xt at return period of 100. So by this value it is already known, and this is already known, that is calculated as this in this case. Then by multiplying, this is what? It's equal to how much? This is this value. It is equal to this value. Then substitute. It's equal to x at 500 return period minus xt. It is already x at 100 return period. It is already given. So this x of at this return period is equal to this value. This value. So it is a required one. The mean annual flood of a river is 600 meter cube per second. Standard deviation of annual flood times race is 150 meter cube per second. What is the probability of a flood magnitude of 1000 meter cube per second occurring in a river within next 5 years? Use Gamble method and assume the sample size is very large. It is very large. Given there is what? The mean flood, there is standard deviation, and there is what? N, n, number of n for 5 years, and sample size is very large. Those are a given, and the required one is the probability of a flood magnitude of 1000. How many it is occur? The probability of occur at least one. At least one. Now it is a given value. It's already given. Then x equal to x bar plus k delta n minus 1. From this we can estimate k is frequency factor is equal to x t minus x bar over delta n minus 1. By using this formula we can estimate kt. Now 1000 it is xct is 1000. Xct is equal to what? 1000 minus what? 600 over what? Standard deviation 150. So by using this formula we can get this value. Yeah, this is get from this. Then yt minus at for a very large sample of data, yn is equal to this value, is constant, and it is Sn. Yeah, if the sample size is very large, yn and xn are very large. So the probability of the occurrence of a flood magnitude 1000 meter cube per second is equal to, yeah, probability, how much? The probability of the occurrence of a magnitude of flood magnitude is equal to what? P, how much? Yeah, P probability is equal to 1 over period. So first to compute a return periods. Return period is equal to, among this equation we can estimate the return period. Yeah, return period. That means first compute yt is equal to minus ln time ln t minus 1, then 1 over not this, ln of t over 1 over t minus 1, it is equal to what? It is equal to e the power of yt. Yeah, e the power of yt. Yeah, by using rules of natural logarithm. Yeah, anti-logarithm. Yeah, it is a rules of anti-logarithm. And next, and also there is ln value. This is already e the power of what? 3.997. So it is value. It is constant value. Then it is also there is a ln. So t over 1 over t minus 1, it is equal to what? Natural logarithm exponential is the power of what? E the power of yt. So this is equation. It is t. Yeah, not t. Yeah, it is t. It is formula. So by using this formula, t over t minus 1 is equal to this value. Then change to then calculate the t value. It is equal to 54.9 years and 55 years. Then the probability of this is equal to p 1 over 50 is equal to this value, and also the probability of flood magnitude 1000 meter cube per second occurring at least once in 5 years, at least one. So p1 is equal to 1 minus p the power of 5. It is a project. Yeah, the life of the project. Then we can get this value. We can estimate, yeah, at least 5 times, at least 3 times, at least it can say at least once, 2 times, 3 times, 4 times. So for example, we can say 3 times, use a permutation, yeah, permutation equation in order to determine the probability. It is very simple examples. You can see easily. Yeah, it is very simple. There is a risk. So from the risk we can calculate what? Can calculate the return periods. 50 it is the life period of the structures, and there is standard deviation, and the annual discharge, mean annual discharge is already given. So by using these values we can estimate what? The required one. It is very simple. We can compute, and we have an equation. We can write in your comment. Yeah, if you have any suggestion, question, and any other ideas, we can just send it to in writing comments. Thank you for your attention. Goodbye.